Okay, today we'll see on the structure of nephron as well as the function of nephron. Okay, this nephron now, it will lie in between the cortex and the medulla. Okay, this is the cortex and this is the medulla. Okay, this is the structure of kidney. Okay, this is the structure of kidney, and this nephron, it will lie here in between the cortex and the medulla. Okay, in the kidney there was different areas, isn't it? Capsule, cortex, medulla, 3 areas. So this nephron, it will lie in between the cortex and the medulla. Means if you see in the microscope, you will be able to see it in this way. Okay, so this kidney, how many nephrons does it have? You will say that you will have approximately 1 to 2 million number of nephrons are there. Okay, 1 to 2 million number of nephrons are there, and these nephrons, they are the structural and functional unit of kidney. STRU, it will be a bit spelling mistake is there. Structural. Yeah. These nephrons, no, they are the structural and functional unit of kidney. Okay. So these nephrons, what do they do? Yeah. In the nephrons, you will see a glomerulus. Okay, we will discuss afterwards. Glomerulus, convoluted tube, quite convoluted because it is twisted. Okay, it is twisted, it is convolved, it is not straight. So for that, it is known as convoluted. Okay, so this is about the nephrons. Okay, the nephrons, they lie in between the cortex and the medulla. Okay, they lie in between the cortex and the medulla, and you will find that these nephrons, they are the structural and functional unit of kidney. Okay, and you will see that about 1 to 2 million nephrons are present there. Okay, so are you clear? Are you clear about the location of nephron?
Ma'am, repeat again.
The nephrons, where do they lie? This is your kidney. Okay, we are zooming in. We are zooming in this kidney. So this kidney, inside the kidney, you'll find nephron. Okay, and these nephrons, where do they lie? In between your cortex and medulla. Do you remember the 3 areas of kidney I have explained to you in the last class now? 3 areas of kidney. This one, capsule, cortex and medulla. Do you remember or not? I have explained, but this is the medulla. Okay, and this part is the cortex. This part is the cortex. This is the medulla. Okay, so the nephrons will lie in between this cortex and this medulla. Medulla, they are inside the pyramid. These striations, this line is known as striations. Okay, so these nephrons will lie in between the this cortex. This is the cortex. I'm moving the cursor, means I'm moving the arrow. So this is the cortex and this is your medulla. So these nephrons will lie here. Okay, in between the cortex and the medulla. Okay, are you clear now? Where will lie the nephrons? Are you clear?
Yes, ma'am.
So the nephrons are very small, means you won't be able to see with your eyes. So would they have a microscope only, like it will be visible. Okay, so they have zoomed in. They have zoomed in, and for that, like, we are able to recognize this thing. We are able to recognize that there is nephrons inside your kidney. Okay, and we have about 1 to 2 million number of nephrons. Okay, and these nephrons, they are the structural and functional unit of kidney. Okay, and the function of nephron are filtration, reabsorption, secretion, and excretion. Okay, we will see one by one how they filtrate, how they reabsorb, how they secrete and how they excrete it. Okay, so these are the main points you can see. These are the main points of nephron. First they will filtrate, afterwards they will reabsorb, afterwards they will secrete, and afterwards at the last they will excrete. Okay, so before going to the function of nephron, let's see the structure of nephron. Okay, so the structure of nephron is this. Okay, so it is in this form. So first you will see this is the Bowman's capsule, or else you can say glomerulus also, glomerulus, or else we can say Bowman's capsule also. Okay, and if we go further, you will see the proximal convoluted tubule. This is the proximal convoluted tubule, or you can say proximal tube also you can say, or else in short you can say PCT also. Okay, why proximal? Because it is near to the Bowman's capsule. Proximal means near. Convoluted means twisted, means it is convolved, it is twisted. Okay, so for that it is known as convoluted. Tubule means why? Because it is tube in shape. The shape of this thing is tube in shape. So for that it is known as tubule, proximal convoluted tubule. Okay, and in the third, what you will see? You will see the descending loop of Henle. Means you will see here there is a loop. Okay, loop. This is known as a loop. So this is the descending loop of Henle, or descending loop also you can say. Okay, and this is fourthly you can see the ascending loop of Henle. Okay, ascending loop of Henle. And the fifth, what you will see the distal convoluted tubule. You can say distal tubule also, or else you can say distal convoluted tubule also, or else in short you can say as DCT also. Okay, so and the fifth is the and the last and the sixth is the collecting duct. Okay, so the last is the collecting duct, and from here the urine will pass and it will go to the renal pelvis, and I will discuss with you later. So for now you just know the structure. First is the glomerulus or the Bowman's capsule. Okay, and secondly you'll find the proximal convoluted tubule, also known as PCT. Proximal, why? Because it is nearer to the glomerulus, that's why it is known as proximal. Convoluted, why? Because it is convolved, it is not straight, so for that it is known as convolved. Tubule, why? Because it is tube-like structure, so for that it is known as tube. Okay, and third you will see the descending loop of Henle, this one. Okay, descending loop of Henle you will see. Fourthly you will see the ascending loop of Henle. Fifth you will see the distal convoluted tubule. Distal, why? Because it is far away from the glomerulus, so that's why it is known as distal. Okay, distal convoluted tubule. And sixthly you will find the collecting duct. Okay, are you clear about the structure now? Structure of nephron, are you clear?
Yes, ma'am.
Okay. Okay, so I was saying now that the function of nephron is what? Filtration. Okay, first they will filtration, then reabsorption, then secretion, then excretion. So now we will see one by one how these nephrons will function in different parts. Okay, in different parts of the nephron, I have explained to you the different parts of nephron. So now we will see how it will function. Okay, how it will filter, how it will reabsorb, okay, and how will it secrete, and how we will see now. So in the first one you can see the glomerulus. This is the glomerulus. Okay, glomerulus. So I'm zooming in. I'm just zooming in the glomerulus, and I'm showing you in this side. Okay, so this is the glomerulus, or else you can see as Bowman's capsule also. Okay, this is the Bowman's capsule. and it is like a cup, like, huh?
Yeah.
Yes, Rudolph.
Okay.
And it is like a cup shape. Okay, cup shape in structure. Okay, this Bowman's capsule glomerulus, it is a cup shape like structure. And here what you will get, you will see here there is efferent arterial, and this is the efferent arterial. Okay, in this glomerulus, I'm just zooming in and I have shown you in this part. You can see that, there is two arterial. Okay, that is the efferent arterial and the second is the efferent arterial. So in the efferent arterial, what will you see? Blood will flow. Okay, all this blood are impure, not pure blood. Okay, all this blood will flow, all the impure blood will flow here. And what will happen here? What will happen here in this glomerulus? Okay, these glomerulus are tough, tough like structure. Okay, they are just like a cup shape. And what will happen here in the efferent arteriole, when the impure blood will come in this glomerulus, they will filter it. Okay, they will filter it, but only 1/5, only 1/5, only 1/5 of the blood will get filtered, and the filtered blood, or it will become pure blood, isn't it? So it will go back to the efferent arteriole. It will go back to the efferent arteriole. Okay, did you understand? Did you understand? Na? So I'll just repeat again. So this is the glomerulus. In this glomerulus, you will see the Bowman's capsule. Okay, you will see that there is a Bowman's capsule. And what you will see here in the Bowman's capsule, you can see that there is efferent arteriole and there is the efferent arteriole. Okay, and you always remember the length of the efferent arteriole. Okay, the length or the diameter of the efferent arteriole is always greater than the efferent arteriole. Okay, why so? Because the blood will flow here, all the impure blood, you can say. Okay, all the impure blood will come and flow towards this efferent arteriole. Efferent means what? Coming in. Okay, coming in, the blood will come inside. So efferent. Okay, efferent arteriole, the impure blood will come inside this and it will get filtered in this glomerulus. Okay, it will get filtered in this glomerulus, but only 1/5, only 1/5 of the blood will get filtered. And that 1/5 filtered blood, it will go towards this efferent arteriole. This is the efferent arteriole. Okay, so the blood will, all the pure blood, okay, only 1/5 of the blood will get pure, I mean filtered, and those impure pure blood or filtered blood, it will go to the efferent arteriole. Okay, efferent arteriole, and it will pass to different parts of your body. Okay, so that is all about the efferent and the efferent. Efferent means go away. Okay, go away from the glomerulus, because it will have to pass the pure blood to different parts of the body. So for that, it has to go away. Okay, efferent means coming in. You remember, coming in, and efferent means going back. So the size of efferent arteriole is also smaller in size. Okay, because it will get filtered, isn't it? Will get filtered, so for that the size is also smaller in size compared to the efferent arteriole. Okay, are you clear now regarding this Bowman's capsule? Are you clear?
Yes, ma'am.
Okay, so this is what happens in the glomerulus. Okay, filtration of blood will happen and the filtered blood will go to the efferent arteriole, and whatever components which are not filtered, for example red blood cells, okay, or larger molecules like proteins and all, it won't be filtered there. So what will do, it will happen in all these parts. Okay, So this is all about the glomerulus. That is the first part. Are you clear about the first part, how it gets filtered, how it works? Are you clear? If you are clear, we can move to the next part, that is the PCT. Are you clear?
Yes, ma'am.
Okay. If you are clear, then okay, let's move to the next part, that is the PCT, that is also known as proximal convoluted tubule. Okay, also known as the proximal convoluted tubule. So in this PCT, what will happen? You will find that all the filtrate, okay, all the filtrate was what like red blood cells, okay, whatever, it won't get filtered, okay, the leftover ones you can say, okay, red blood cells, molecules like proteins, all this, it will move towards this PCT, okay, it will move towards this PCT. And what will happen here, in this PCT you will also get urea, uric acid, creatinine and all also, okay, in this PCT. And what will happen here, two-third, okay, two-third of the filtered salts and water, okay, of glucose, amino acids, all these they will get reabsorbed, okay, all this they will get reabsorbed in this portion, you can say, in this PCT, all this like ions, water, nutrients, okay, all this they will reabsorb, they will get reabsorbed and they will adjust in filtrating pH. pH means what, power of hydrogen, okay, power of hydrogen. In power of hydrogen, what you will get, acidic, basic, means it will try to be neutral. Neutral point is 7, isn't it? pH, power of hydrogen is neutral point is 7, isn't it? So it will try to adjust in this part, okay. Did you get, are you getting my point? In this PCT, what will happen? The first point is filtration. You remember, no, filtration. Here filtration will happen in this glomerulus. Now the second point is reabsorption. Again, it will reabsorb. For example, ions, water, nutrients. Okay, and it will remove toxic particles, and it will try to adjust with the filtrate pH. pH means power of hydrogen. Okay, in the power of hydrogen you will be getting acidic, basic, and the neutral point of pH is 7. So it will try to adjust in this part. Okay, are you getting PCT, proximal convoluted tubule? Everyone, did you
Yes,
understand
ma'am.
what happens in PCT?
Yes, ma'am.
All the filtrate particles now, whatever like you got now for RBC, then molecules like proteins, all this it will come in this PCT, all the filtrate portion. And this filtrate part, what will they do? They will reabsorb ions, they will reabsorb water, nutrients, and they will remove toxin. Okay, and they will adjust with the filtrate pH. Okay, filtrate pH means power of hydrogen, that is in the power of hydrogen you will be getting acidic, basic, and the neutral point is 7. Okay, so so these things happen in PCT, that is the proximal convoluted tubule. Okay, but in this PCT what you will get, they don't want to lose glucose, sodium chloride, okay, by the reabsorption method. So for that they will stick it like glucose and sodium chloride. Okay, so for that they will stick to it in this PCT. Did you get PCT? Shall we move to the next? Shall we move to the next? That is descending loop of handling. Okay, let's move to the next partner. That is descending loop of handling. So in the descending loop of handling, what you will get? In the descending loop of Henle, you'll get aquaporins. Aquaporins means what? Means water permeable, means water will be able to flow. Okay, aquaporins means where water can flow freely. Okay, so this is the meaning of aquaporins. So in this descending loop of Henle, what you will get? Aquaporins allow water to pass from the filtrate into the interstitial fluid. Okay, so in this descending loop of Henle, what you will get? Water will be able to flow, means the water will be able to get dilute. Okay, it will be able to get dilute, and what will happen? It will pass from the filtrate into the interstitial fluid. All the filtrate particles, it will be easy to get into the interstitial fluid. Interstitial fluid means what? Where there is mixture of ions, okay, water ions and small solutes. Okay, and it is also interstitial fluid. You will get, they also monitor the glucose level. Okay, as I've already said, now in the proximal convoluted tubule, they don't want to leave glucose. So in this descending loop of Henle, what will happen? They will again gain the glucose in this descending loop of Henle, and water is able to flow, means water permeable. Okay, water is able to flow, and here what happens? It will get filtrate and it will pass into the interstitial fluid. Interstitial fluid means where there is mixture of water, where there is mixture of ions and small solutes. Small solutes means what? Which is permeable to water, means where water will be able to flow. Okay, and here what will happen? And here monitoring of glucose is also done. Means we can see in this descending loop of Henle. Okay, did you understand descending loop of Henle? What happens in the descending loop of Henle? Did you understand what in descending loop of Henle what happens? Huh?
Aquaporins Aquaporins allow water to pass from the filtrate into the interstitial fluid.
Huh. Aquaporins means what? Permeable to water. Permeable to water means water will be able to flow, will able to mix with it. Okay.
Yes.
Aquaporins means that one. Okay, in the descending loop of Henle, what happens? Means water will be able to dilute, will be able to flow, and what will happen? It will go into the interstitial fluid. Okay, all the filter particles, it will go into the interstitial fluid. Interstitial fluid means mixture of ions, water, okay, all this. And here what will happen? You will find that glucose level is also monitored here in this descending loop of Henle. Okay. Okay, let's move to the next part, that is the ascending loop of Henle. Okay, ascending means greater. Okay, ascending loop of Henle, what you will find here in the ascending loop of Henle, okay, as the nephron, as the loop of Henle, it is going deeper. Okay, so you'll find that more concentration of salt, there will be more concentration of salt in this ascending loop of Henle. Okay, and it will be salty also. But what will happen here? They won't allow water to move out. Okay, in this what will happen? They won't allow water to move out. In the descending loop of Henle, so they were allowing water to move out, isn't it? But in the ascending loop of Henle, what you will get? You won't find aquaporins here. Okay, aquaporins. You won't find aquaporins here because uh, it's very salty. Okay, and you will find here spatial ion channels that pumps out this one. Okay, the thing is the ions is known as NaCl, that is sodium chloride. So for this also the deeper part is salty. You'll find it salty also. Okay, so in the ascending loop of Henle you will find that there is reabsorption. Okay, remember no, filtration then reabsorption, remember no. So here reabsorption will occur. Okay, reabsorption will occur here, that is reabsorption of sodium and chloride, okay, from the filtrate into the interstitial fluid. Okay, reabsorption of sodium and chloride again will happen from the filtrate into the interstitial fluid. Okay. Okay, did you understand? In the ascending loop of Henle, what will happen? As it is deeper, okay, it is pura downside of the what to say, medulla. What you will get, you will find that it's salty, and they will have some special ions that will pump out, means ions. That ion is sodium chloride. Okay, and this sodium chloride, what will they do? They will again reabsorb. Okay, they will again reabsorb from the filtrate. Okay, filtrate was here, filtration was done here, so they will filtrate and it will go into the interstitial fluid. Okay, interstitial fluid was what? Mixture of water, ions, okay, all this thing will occur in the ascending loop of Henle. Reabsorption will occur. Okay, did you get ascending loop of Henle? Okay, now let's go to the next, that is the distal convoluted tubule, also known as DCT. Okay, so in the DCT, what will happen? They will selectively secrete and absorb different ions to maintain blood pH and electrolyte balance. Means whatever is coming from this ascending loop of Henle, means in this DCT, that is a distal convoluted tubule, they will select now. They will select and they will secrete and they will absorb all the different ions to maintain the blood pH level and electrolyte balance. Okay, this thing will happen in the DCT. There will be reabsorption of ions also. Reabsorption of ions like calcium, sodium, all this. So all this thing will happen here in the secretion, means in this DCT. And this DCT is just the opposite of reabsorption. Okay, reabsorption means ascending loop of Henle. It is just the opposite of ascending loop of Henle. Here they will select. Here they will select and they will secrete. They will absorb all the different ions like sodium, okay, calcium. All this they will reabsorb, and they will try to maintain blood pH, okay, power of hydrogen, and electrolyte balance. So this is about DCT, that is the distal convoluted tubule. Okay. Okay, are you clear? So are you clear or not?
Yes, ma'am.
Okay. So after this DCT, what will happen? All the reabsorbed salt, okay, all the reabsorbed salts such as electrolyte, glucose, amino acids, all the waste, or whatever waste particles are being there, it will go to this collecting duct. Okay, it will go to the collecting duct, and what will it do? This collecting duct? Collecting duct is like a drain. Okay, it will drain, means they will reabsorb the solutes and water from the filtrate, means whatever work was being done here now, means whatever the unwanted particles, whatever they will get, they will reabsorb all the solutes and water from the filtrate, means they will do here. And what will happen here? They will drain out all the unwanted particles and it will move to the renal pelvis. Okay, renal pelvis, do you remember? Renal pelvis. This is the renal pelvis, Here was the nephron. Okay, here was the nephron in between the cortex and the medulla. Okay, then now after the collecting duct, okay, after collecting duct, the urine means the unwanted particles or the toxic particles, it will move towards the pelvis. It will go towards this pelvis and it will go to the ureter, this ureter, then urinary bladder and urethra. So in this way, the formation of urine is occurring. Okay, did you understand? Did you understand, everyone?
Yes, ma'am.
Okay, are you all clear about this? If you want, you can note it down this one, because if it will be easy for you. Means here now, part by part, it's there. So are you clear? So I'll just show you again. Means here all the unfiltered blood. Okay, there is the efferent arterial. It will go. Okay, it will go and it will move towards the filtered blood. It is the efferent arterial, and here is a nephron. Okay, in between the cortex and the medulla, and after that it will go to the renal pelvis. This is your renal pelvis. Then afterwards, the urine will come out. This one. In this way, urine formation occurs. Okay, are you all clear? The function of nephron first is filtration, afterwards they will reabsorb, afterwards they will secrete, and afterwards at last excretion. Excretion will happen in collecting duct, and reabsorption will occur in where? Reabsorption will occur in PCT, okay, and ascending loop of Henle. And filtration will occur here, glomerulus. Okay, and secretion will occur here in this DCT, distal convoluted tubule, and excretion will occur here, that is in the collecting duct. Okay, are you all clear? In which part secretion, filtration, reabsorption, secretion, excretion occurs? Are you all clear? Are you clear or not? If you are clear, Caroline and all, are you clear? Are you clear, Caroline and all? Are you clear or not? Huh? Are you all clear? Gordas, are you clear? Are you all clear? Hello? Are you all clear about this? Function of nephrons? What are the parts of nephrons? Taba Anyam? Parts of nephrons? Parts of nephrons. What are the parts of nephrons? Name them. Parts of nephrons.
Glomerulus.
Then
4
Proximal.
types, ma'am.
then what?
Loop of Henle. Ascending loop of Henle. Distal tubular. Collective.
Okay, where filtration occurs? In which part?
Pardon, ma'am?
In which part filtration occurs? Filtration of blood.
Descending loop of Henle.
Are you sure? What I was saying is the impure blood comes from this efferent arterial. Okay, efferent arterial, and it will get. Means it will. They will filter and it will become pure blood now. Okay, in the glomerulus, and about 1/5. You know the 1/5, 1/5, 1/5 of the means filtered blood will go towards this efferent arterial, and whatever was left out, no, it will go into the proximal tubule. All the filtrate part, you can say, means whatever it was not being filtered, it will go towards this proximal convoluted tubule. Okay, so this thing will happen here. Okay, Tannu Gurung, can you hear me? Can you hear me, Tannu Gurung? Can you hear me or not? Say. Okay, Tashi. Tashi, can you hear me? Tashi, can you hear me? Tashi, can you hear me or not? Okay, Yangbiu Jumi. Yangbiu Jumi, can you hear me? Huh? Yangbiu Jumi. Yangbiu Jumi, can you hear me? Okay, Gordas. Can you hear me, Gordas? Okay, Kajal Kumari.
Yes, ma'am.
Okay, what do you mean by aquaporins? What do you mean, what do you mean by aquaporins? Huh?
Um, ma'am, I forgot.
Means where water can flow. Okay, where
Okay,
water is
ma'am.
able to flow. Means yeah, where water will be able to flow. Where water, means there will be controlling of water. Okay, that one is known as aquaporins. Where water is able to flow. Okay, that means aquaporins. Don't forget.
Okay, ma'am.
Okay. And which part is more saltier? Descending loop of Henle or ascending loop of Henle? Which one is more saltier? Kajal? Ascending or descending?
Yes, ma'am. Ma'am, descending.
Okay, you will find.
Yes, yes, ma'am.
Yes,
Ascending.
okay. And you will find that water does not flow here. Okay, they won't allow water to flow here because aquaporin system is not here. It is ascending loop of Henle. Okay,
Okay, ma'am.
okay. Okay, we'll end the class here now. And after this class, you'll be having your anatomy class. Okay, reproductive system. I didn't complete the reproductive system. I will complete it. Okay, for now, your class is over. You join again. Okay, after 3-4 minutes, you join it again.